పోనీ యూట్యూబ్ లింక్ అయినా వింటున్నానంట, అది కూడా లేదు. Today we are going to discuss graphs continuation only. So in the graphs, paths and cycles are there. So what is a path? And that means path is nothing but a walk. Path is nothing but a walk. So that here a walk from vertex x to another vertex. So some vertex to another vertex, some walk is there. This is nothing but path. That means in this walk it contains a number of or sequence of edges. Suppose for example you can observe here a0, a1. So here a2, a0 to ak are the vertices. So here edges from a0 to a1 and a1 to a2 and a2 to a3, like that ak minus 1 to ak. That means path is nothing but it is a walk from one vertex to other vertex in a graph. So it is a sequence of edges. It contains some sequence of edges. Suppose here a0 equal to a and ak equal to b. So that is the sequence of edges e1, e2, en, where so that means each and every vertex is connected with other one, some vertex. That means where ei connects some vertex ai, then the next edge is ei plus 1. That means here ei is connected some vertex to ai. Here suppose some edge is from here to here, ei is there. So this ei is connected to some other edge, that is other vertex, that is ai. Then the next edge is ei plus 1. So it connects that vertex ai to the some other vertex, so that it can form some walk. So that walk is from a to b. So here a0 is a. This a0 is nothing but a. Here this a0 is nothing but, here a can assume here a0 equal to a and last one, this is the initial point and this is the final point or end point. So this initial point is a and final point is b. Now the sequence of edges, that means e1, e2, e3 and so on ek, all these edges, sequence of edges are there. So the sequence of edges are there. So these sequence of edges. Now the sequence of edges, how these sequence of edges are formed. For example, suppose ei connects some vertex. That means suppose you can assume here like this number of edges are there. Here ai minus 1. That means ai minus 2 ai is there. ai minus 2 ai minus 1. There is a edge on ai minus 2 to ai minus 1. So that edge is nothing but ei. So now that edge is connected to some other vertex to ai. That means ai minus 1, like that some other. Suppose this is you can observe here, this is some edge. Now this edge is connected with some other vertex a4. Then that means a2 to a3 some edge is there. From a3 to a4 some edge is there. That means this is some edge. This edge is connected with some other vertex. Then the next edge is ei plus 1. Again that the I plus 1 connect with other vertex. Okay, like ai to some other vertex. So thereby forming a chain of connected vertices. That means a1 to a2. Sorry, a0 to a1, a1 to that is a1 to a2, next a2 to a3, like that it forms some chain, or it forms some connect, that means chain of connected vertices from A to B. For example, this is nothing but A and this is nothing but B. So from how to connect these vertices A to B through some chain of edges. Okay, these chain of edges is called as path, or simply say that walk. The length of path is nothing but the number of edges. That means the number of edges that form the length of the edge. That means that path contain how many number of edges. That is nothing but length of the edge. Suppose you can observe here. This is some example here. A to B, B to C, and C to D, D to E is some path. Okay. So from here to here, how many number of the path of this A to E is what? A to E's path is nothing but what? From A to B and B to C, as well as C to D and D to E. So here the path of, you can take this path. In this situation, the length of the path is what? 1, 2, 3, 4. How many number of edges are there in that path? That is nothing but length of the path. And suppose you can take here from A to B, edge is there, from B to E is also edge is there. So now the path is what? Here the path is now A to D, A to B one path and B to E one path. That means the length of this path is 2. And next one more is A to D, some paths exist or some edges exist. From D to E some edges exist. That means the path between A to E, A to D and D to E. That means there exist three paths from A to E. Okay, those three paths have the length, two paths have the length 2 and one path have the length with 4. That means A to E here the length is 4, A to E here the length is 2, A to E here the length is 2. Okay. Now if formal definition for this, if P equal to A1, A0, A1, A2 and so on, AK minus 1, AK. So is a walk, then K minus 1, then it refer to the walk from A0 to A0 to AK. Otherwise this is undirected graph, nothing but. So there is a path exists from AK to A0 also. That means A0 to AK paths exist with how many number of edges? K minus 1 number of edges. So here P equal to A0 to AK is a walk with K minus 1 edges. Then it refers a walk from A0 to AK or AK to A0. So here P connects A0 to AK. Here A0 and AK are called terminal points. This is a terminal points, nothing but end points. So this is the initial point and this is a terminal point. Now, so here another example is there. So this is another example. So here A, B, C, D, E, F. These all are the edges. So in this above graph is a that means is a path of length. This is A from A to B and B to C and C to F, F to E and E to D. F to E and E to D. So is a path of length 5. That means suppose you can observe here how many number of vertices are there. 1, 2, 3, 4, 5, 6 vertices are there. Suppose all these vertices one time మనం విజిట్ చేస్తున్నాము అంటే now the length is what? That means from A to B path is there, from B to C path is there, from here coming to here C to F is some path is exist, from F to D path is exist and D to E path is exist.
Yes.
In this path all the vertices are there. So here total 6 vertices are there. Then the path length is what? 6 minus 1. That is length of this path is 5. Here A and E are the end points. Here you can observe this is the path. In this case A and E are the end points. Suppose you can take the path from D to A. D to A. Here you can assume that D and A are the end points. Now how you can form the path? From D to B path is exist, from B to E edge is there and E to F edge is there, and next F to C edge is there and C to A edge is there. Here end points are D and A. So that's why D to B, B to E to F, F to C and C to A. So this is a path with length 5. Okay. Now this path is also represent like this sequence of vertices or sequence of edges also. Here in this case AB is one edge and BC is one edge, CF is another edge and FD is another edge, DE is another edge. That means a path is represented by using sequence of edges or number of vertices, or sequence of vertices or sequence of edges. So a path is a walk whose vertices are distinct. Suppose you can take the path here. So compulsory vertices are different. In the path vertices are distinct. In the path vertices are distinct. Suppose you can observe here D to B, B to C and C to D to B, B to E and here from F, next to D, next to E, next to C, next to A. So in this case you can observe here D is repeated 2 times. In this case we are saying that this is not a path. That means path in the sense each and every vertex can visit only one time. That means in the path whatever the vertices we are choose, those vertices are distinct vertices. Suppose you can, this is a path. A, B, C, F, D, E is a path. Whereas coming to the D, B, C, F, D, B, E is not a path. Because here B is repeated and D is also repeated. Okay. B is repeated here twice. But initial point is there and this initial point is also repeated. So that's why this is not a path. That means D to B is there, B to C and C to F. Next again F to D. Next D to B and again E. Okay. So like this you can move to A also. So here F, F to A. So the different vertices are repeated more than one time. So that this is not a path. For example, you can take this is also not a path. That means A, here A, B and D, next D, E, D, E. So this is also not a path because here because you can observe here BF. That means you can observe here A to B edge is there. Okay, A to B is edge is there and B to F there is no edge, direct edge. From B to F there is no direct F. So that's why this is not a path. That means whenever we can form the path, what is edge sequence and vertex distinct vertices are must. So here edges are vertices are distinct, but there is no path exists between these two vertices. That means in this case, that means suppose you can write the edge sequence for this path AB, BC, CF, FD, DE. So this is the edge sequence. Whereas coming to here, you can write the path. So in this case, edge sequences exist. That is DB, BC, CF, FD, DB and BE. Suppose you can observe here DB. So DB is exist and BC is exist and CF is exist. Next FD is exist. Next BE is also exist. But here edge sequences exist, but the vertices are repeated, so that this is not a path. Whereas in this case vertices are distinct, but there is no edge sequence. That means you can take the edge sequence for this A to B, edge is there, and coming to the B to F, there is no edge. So there is no direct edge from B to F. So B to C is edge is there and C to F is edge is there. Otherwise B to E edge is there and E to F edge is there. Otherwise B to D is edge is there and D to F is edge is there. Otherwise B to A is edge is there and A to F edge is there. So but there is no edge from B to F directly. So that this is not a path. So in the question, that means in the exams they can ask the questions, they can give some graph and find out here this path is existing or not. So we can say that when the path is exist, vertices are different and edge sequence is also exists. So then only we can say that that is the path. And here this is connected and disconnected graph. Suppose you can observe here, these are the two graphs. So this is the disconnected graph. Here one vertex is there. This is not connected. So that this is called as a disconnected graph. So this is called as a connected graph. That means here a connected component of a graph is a subgraph. So that is maximally connected. Suppose here, observe here, this is what connect some graph. So in this case, this is called as a connected component. That is a connected subgraph with the property that any larger subgraph that contains it is that cannot contains. Okay? Here this is a graph. So in this case, maximum all the vertices are connected. But here you can observe vertices are not connected. So that's why this is not a connected component. Suppose you can observe here, this is G is not a connected graph. So this is not a connected graph. That means total, this is a graph. From here to here there is no connected, and here to here there is no connected. So if all the vertices are connected, then this is called as a connected graph. Suppose sometimes this is contains one connected component. This is one connected component. This is one connected component. This is one connected component. But not, this is not a connected graph. So in this above graph has 5 connected components. You can observe here. That means one connected component contains 3 vertices. Other connected component contains 4 vertices. And other connected component contains 2 vertices, and other connected component contains 2 vertices, and one connected component contains only 1 vertex. That means 3 vertices, 4 vertices, 2 vertices, and 2 vertices, and 1 vertices. So here number of connected components in this graph are 5, but this is not a connected graph. So this is not a connected graph. Here some connected components are there. That means 1, 2, 3, 4, 5 connected components are there. So every graph is a union of connected components. That means every graph is, this is one connected component, this is one connected component, this is one connected component. Every graph is called a unique set of connected component. So now a path is a closed if its endpoints are the same vertex. So when we say that the path is closed, if endpoints are same, then we can say that the path is closed. Suppose for example, you can observe here A to B some edge is there, B to E, B to C some edge is there, C to F some edge is there. Next here F to D some edge and D to E some edge. Okay. Now this is, suppose from E to A there is no direct path. So from E to A there is no direct path. So that some vertex is repeated, but endpoints are repeated. So remaining endpoints, whatever the vertex are there in that path, those are not repeated. Okay, in that case this is not, we can call this a closed path. This is not a closed path. That means in the closed path, other than endpoints, remaining all the vertices are distinct. That means here a cycle is a closed walk of length at least 3 whose integer vertices whose integral vertices are integral or internal vertices are all distinct. Suppose you can observe here A to B and B to C, next C to F, F to A. So this is some path. So other than these two endpoints, that means A and A, remaining vertex you can observe all these vertices are different. So that this is called as a closed path. Closed path in the sense endpoints, that means initial point and this end point, initial point and last point, initial one and last one, both are same. That means terminal points are same, but the internal vertices are distinct. Then we can say that cycle is a closed path. This is a closed path because this is a closed path, means endpoints are same. So this is also called as a cycle. So this is a cycle from A to B, B to E, E to F, F to A. This is a cycle and this cycle is a closed path. Suppose you can observe here one more cycle, A to B, B to E, E to D, D to F, F to C. Next F to C, next C to A. Okay, suppose here you can observe here A to B. So from here A to B is A, next B to C, next C to B, again next B to D, next D to F, next F to A. So this is a cycle. This is a cycle. But this is not a path. This is not a closed path. Because other than these two endpoints, you can observe all the internal vertices are repeated. That means here B is repeated. So that's why internal vertices are repeated. That's why this is not a path. So ఒకసారి మనకి vertices repeat అవుతున్నాయి అంటే అది path కాదు. సో అప్పుడు అది ఎప్పుడు closed path అవుతుంది. So other than endpoints, internal vertices are distinct, then we can say that there is a closed path. Suppose if the vertices are same, endpoints are same and internal vertices are repeated, then we can call it as a cycle only but not a path. That means ఇక్కడ internal vertices repeat అవుతున్నాయి, end points సేమ్ ఉన్నాయి అంటే సైకిల్ ఫామ్ అవుతుంది అంతే కానీ that is not a closed path because here internal vertices, B is a internal vertex, that internal vertex is repeated. Okay, so that's why that means every cycle is not a closed path. Every closed path is a cycle. Okay, every cycle is not a closed path but every closed path is a cycle. Okay, next ఇలాంటి పాయింట్స్ పైన మనకి స్టేట్మెంట్ ఓరియంటెడ్ క్వశ్చన్స్, కాన్సెప్ట్ ఓరియంటెడ్ క్వశ్చన్స్ వచ్చినప్పుడు ఇలాంటి పాయింట్స్ పైన అడుగుతూ ఉంటాడు. సో లైక్ ఎవ్రీ దట్ మీన్స్ ఎవ్రీ ఫుల్ బైనరీ ట్రీ ఈజ్ ఏ కంప్లీట్ బైనరీ ట్రీ as well as strictly binary tree. Coming to the strictly binary tree is not a full binary tree. Okay, every complete binary tree is not a full binary tree. Like that some questions, concept oriented questions are asked in the competitive exams. So like this is a path. What is the difference between the cycle and closed path? So suppose you can observe both of those two are same. That means closed path in the sense whenever the end points are same we can call it as a closed path. But whereas coming to the path definition, so in the path all vertices are distinct. So based on that, whenever the cycle is formed, if the cycle contains any repeated vertices other than end points, in that case that is not a path, just that is a cycle only. So if it is a cycle, so in that case internal vertices are repeated, then that is not a path, means automatically that is not a closed path. Here now ABA is not a distinct, is not a cycle. So in this case here ABA, so this is not a cycle because its length is only 2. Suppose you can observe here the length is what, how many number of edges in that work, that is called as length. Suppose in the definition itself, in the first in the definition only we can take that a path is closed if its end points are the same vertex. Okay, and here compulsory the length must be 3, sorry, at least 3, means that a cycle is a closed walk of a length at least 3 whose internal vertices are distinct, then only we can call it as a that cycle is a closed path. అంటే cycle length వచ్చేసి at least 3 ఉండాలి and closed path, closed that means in end points మాత్రమే same and internal vertices are different, 3 points, at least 3 edges, end points are same and internal vertices are different, then that cycle is called as a closed path. Suppose you can observe here, here ABA is not a cycle. So ABA is not a cycle, isn't it? So this is not a cycle because its length is only 2. Its length is only 2. So in the definition of closed path, the length at least 3. length of the closed path at least 3. Here this is a cycle with the length only 2. That's why this is not a closed path. Now coming to here A to B. Observe here A to B, B to E, next E to D, next D to F. So this is not a cycle. It is a path. Suppose you can observe here end points are not same. All the vertices are distinct and edge sequences exist. That means A to B edge is there, B to E edge is there, E to D edge is there, D to F edge is there. Then we can say that this is a path only, not a cycle. Means path కావాలి అంటే మనకి ఏమవ్వాలి, all vertices are distinct and compulsory edge sequences exist in that graph. Edges are exist in that graph. Then only we can say that that is a path. And this is not a closed path because these 2 points are not same. A and F are not same. Next, a graph is said to be cyclic if it contains no cycles. So here this is acyclic andi correct ga raaledu. A graph is said to be acyclic if it contains no cycles, then it is called as a acyclic graph. So now observe here, this is one acyclic graph. Suppose you can observe from this is the node. So from here to here, here to here, from here to here, here to here, next here to here, from here to here, here to here. This is the end. So ikkada manaki ante eppudu kuda ee points manaki connect kavatledu. ఇక్కడ నుండి ఉంది అనుకోండి సైకిల్ అనేది ఫామ్ అవుతుంది. ఇలా ఉంటే సైకిల్ ఫామ్ అవుతుంది, ఇలా ఉంటే సైకిల్ ఫామ్ అవుతుంది, ఇలా కనెక్ట్ అయిన సైకిల్ ఫామ్ అవుతుంది, ఇలా ఉన్న సైకిల్ ఫామ్ అవుతుంది. దట్ మీన్స్ now this is called as a acyclic graph. Here this is called as a acyclic graph. So this is also called as a free that means this is also, suppose there is no connection from here to here, so now this is called as a forest. Okay, a tree is called a rooted tree. It is defined to be a connected acyclic graph with one distinguished node. That means suppose you can observe here one node. So from this node to we can reach all other nodes. Okay, some other nodes from here. Suppose there is a path from here to here. Yes, some path is exists from here to here. So next some path is exists from here to here. Some path is exists from here to here. Then we can say that this is called as a tree. That is, tree is a rooted tree. Okay, it is defined to be a connected acyclic graph. Acyclic graph means there is no cycles with one distinct node. That distinct node is designated as root. That distinct node is designated as root. So here one more concept, there is a spanning tree. Spanning tree nothing but what? That means that contains all the number of vertices, but coming to the edges are subset of edges. Then we can call it as a spanning tree with there is no cycles. అంటే ఒక గ్రాఫ్కి స్పానింగ్ ట్రీని ఫామ్ చేయాలి అంటే యూ కెన్ కీప్ ఇన్ మైండ్ 3 points. One is number of vertices. Whatever the vertices are there in the graph, those vertices are there in the spanning tree. And so while choose the edge among the vertices, there is no cycle is formed. Okay, there is no cycle is formed. Okay, this is compulsory connected component, means single connected component, means all the vertices are connected. Okay, suppose you can choose one node as a root node. So from that root node you can move all the other vertices. Then we can say that that is a spanning tree. Okay, so this is what about the spanning tree. Already we have discussed about this diagraph concept. So just here I can discuss about only paths and what is that cycles, closed path. Okay, so we know that this a directed path is nothing but there is an edge from A to B. There is no edge from B to A. Okay, this is called as a ordered pair. How this ordered pair is represented in the parenthesis. So coming to the unordered pair, how it is represented in the flower basis. That means there is an edge exists from A to B as well as B to A, but here edges exist from A to B only. So this is a representation for directed graph like undirected graph. V comma E, here V is a set of vertices and E is a set of ordered pair of elements. Ordered pair of elements. Now here edge instant from one vertex and instant to other vertex. That means suppose this is a directed graph. In the graph, that means only undirected graph, edge is instant on. That means A to B some edge is there. Here some edge is instant on A as well as some edge is instant on B. There is no concept of instant from and instant to, because in the undirected graph there is no direction. That means edges exist from both sides. So that there just we are use the term as instant on. Whereas in directed graph, here instant from vertex to instant to another vertex. That means here suppose you can observe this is the graph. Here edges are, that means 1, 2, 3. 3 edges are instant to A. 3 edges are instant to A. That means this edge is instant from B to edge is instant to A. Here edge is instant from B to A. That means B to A. Edge is instant to A. Here edge is instant to A. Here also edge is instant to A. That means all other 3 remaining vertices. Suppose you can observe here B. Here 2 vertices are instant from this vertex B. 2 vertices are instant from this vertex B. Here 2 edges are instant from this vertex C and 1 edge is instant to C. One edge instant to C, 2 edges instant from C. Suppose you can observe for D, 1 edge is instant to D and 1 edge is instant from D to A. 1 edge is instant to C to D. Okay. So this is what the concept of instant to and instant from. So based on this instant to and instant from, out degree and in degree is defined. That is, the out degree of a vertex is number of edges that instant from. How many number of vertices are instant from one vertex to another vertices, that is called as out degree. That means the out degree of this B is what? 2. What is the out degree of C? 1. 2. 1 and 2. What is the out degree of D? 1. Coming to the out degree of A is 0. No edge is instant from this vertex. That's why the out degree of this vertex is 0. Next, here the in degree of vertex E is the number of edges instant to it. How many number of vertices are instant to it is called as in degree. That means here the in degree is 3 and here in degree is 0. There is no vertex there is no edge instant from one vertex to B. Okay, so that in degree is 0. Here in degree is 1. That means one edge is from B to C. Here in degree is 1 because one edge is from C to D. So that means out degrees of this one is in degree and out degree. So first of all, see here this is what vertex set. A, B, C, D is the vertex set, and coming to the edge set. Here B to C, B to A edge is there. Next B to C edge is there. Next C to A is there and C to D is there. D to A is there. How many number of edges are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here vertex A has in degree 3, out degree 0. Vertex B in degree 0 and out degree 2. Here vertex C in degree 1 and out degree 2. Vertex D in degree 1 and out degree 1. So this is called as the in degree and out degree sequence. So this is nothing but in degrees and out degrees. That means here first in degree and out degree. That means 0, 3 and 0, 2, 1, 2, 1, 1. So in the exams, ask the questions like this. They can give some edge sequence, degree sequence, that is in degrees and out degrees are given. So find out using this in degrees and out degrees there is any graph is formed. So if the graph is formed, whether that is a cycle or where here any path is exist, like that. So different types of questions are asked based on this degree sequence also. Next here, if G is a diagram with m edges, so G is some diagram with m edges, then the same out degrees is equal to n, and the sum of all, if G is a diagram with m edges, then the same number of out degrees is equal to so this is some graph with m number of edges. Here m number of edges, that means 1, 2, 3, 4. Like that, how many number of edges are here? 1, 2, 3. That means here this is undirected graph. Here how many number of edges are there? That means if G is a diagram with m edges, then the same out degree, that out degree is equal to n, and the same of the question is the present statement. It means what here, if m number of edges are exist, that is a complete graph. So in that case, same number of in degrees and same number of out degrees. That means in the complete graph, it contains m number of edges. In that case, the sum of out degrees equal to sum of in degrees. So this sentence tappandi raskondi. If G is a diagram with m edges, then the sum of out degrees is equal to sum of all in degrees equal to n. Write down that statement. If G is a diagram with m edges, then the sum of out degrees is equal to n, and the sum of all in degrees, this is in degrees, is equal to 1, equal to n, equal to n, means sum of in degrees and sum of out degrees equal to n. So in the complete graph, suppose observe here, this is the complete, this is the graph, here you can observe here in degrees and out degrees. Suppose 0, 2, 2, 0, 1, 1, 1, 2. Okay. If diagram with m edges, I am not saying that there is a complete graph. Here, if G is a diagram with m edges, then the same sum of out degrees is equal to n, and sum of out in degrees is equal to n. Suppose observe here. Suppose this is a graph. So in this graph, this is, you can take it as an undirected graph. You can observe this is an undirected graph. Otherwise, you can take the direction both sides. So from here to here, here to here. So in this case, here, that means in degree is 4 as well as out degree is 4. Ikkada directions ivvaledu. Write down directions both sides like this. Okay, like this. Right, both sides can draw the directions. So then the sum of in degree is equal to sum of out degree. Suppose you can observe here in this figure. Suppose here sum of in degrees, in degree for this vertex is 0 and out degree is 2. Here 1 in degree and 1 out degree. Here 1 in degree and 1 out degree. Here also 2 in degrees and out degree is 0. How many number of edges are there? 1, 2, 3, 4 edges. So if 4 edges are exist in this graph, then number of sum of in degrees equal to sum of out degrees. That means observe here 4 equal to 4, means in degree and out degree is same. that is the total number of edges, the total number of edges, the total number of edges m, the complete diagraph on n vertex. That means the total number of edges in the complete diagraph. అంటే అప్పుడేంటి మనకి ఎన్ని వర్టిసెస్ ఉండొచ్చు అంటే n vertices are there. So total number of edges m, then the complete diagraph on n vertices. Suppose n vertices ఉంది అనుకోండి, n vertices 1 2 3 4 5 vertices are there. So then total number of edges are m total number of edges. That means m is in the sense what అండి ఇక్కడ number of edges. ఇక్కడ మీరు edges అబ్జర్వ్ చేస్తే ఎన్ని edges ఉంటాయి, ఇక్కడ 20 edges ఉంటాయి. Because this is a complete graph, 20 vertices are there. Suppose for example, if n equal to 5, so when this is a complete graph, so how many number of edges are there? 20 edges are there. So automatically అప్పుడు ఏమవుతుందండి, in degree ఏమవుతుంది 20 అవుతుంది, out degree 20 అవుతుంది. That means in degree value is nothing but number of edges. The total number of edges m in the complete graph, that m is nothing but what? Total number of edges. Suppose for example, here the total number of edges m, that is equal to number of sum of in degrees or sum of out degrees in the complete diagraph on n vertex. So write down this point also, this is wrong here. The total number of edges m, it is equal to sum of in degrees and or sum of out degrees if that complete graph on n vertices. That means the total number of edges m is equal to sum of in degrees or sum of out degrees, then the graph is complete graph on n vertices, complete graph on n vertices. Suppose you can observe here, if n equal to 5, okay, n equal to 5 is complete diagram, then the total number of edges 5 into 5 minus 1, that is 20, that is n into, if the complete diagram contain how many number of edges with n vertices, that is n into n minus 1 edges. Okay, the number of edges in any diagram on n vertices, the number of edges on అంటే మినిమం టు మ్యాక్సిమం ఎన్ని ఉండొచ్చు అంటే m లెస్ దాన్ ఆర్ ఈక్వల్ టు n ఇంటూ n మైనస్ 1. సో మ్యాక్సిమం ఎన్ని ఎడ్జెస్ ఎగ్జిస్ట్ అవుతాయి మనకి, దట్ ఈస్ n ఇంటూ n మైనస్ 1. సో మినిమం m ఈజ్ నథింగ్ బట్ మినిమం 0 టు n ఇంటూ n మైనస్ 1. దట్ ఈస్ మన నంబర్ ఆఫ్ ఎడ్జెస్ ఆర్ లెస్ దాన్ ఆర్ ఈక్వల్ టు n into n minus 1. Now the another concept, that is the embedded graph. Every graph is embedded obtained by converting that means each directed edge into undirected edge and then remove the duplicate edges. That means how this is some graph. So this is some directed graph. Remove all the edges. That means remove all. Every diagram is embedded graph obtained by converting into direct, that means its directed edge into undirected edge and then remove the duplicate edges, that is and loops and this ఇవి రిమూవ్ చేసినప్పుడు మనకి వచ్చేది ఏదైతే ఉంటుందో దట్ ఈస్ కాల్డ్ యాజ్ ఏ undirected graph. That means a to b there is no direction, b to c there is no direction, c to d there is no direction, d to a edge is there, a to d is also edge is there, so that only one edge. And from a to c, here రాయలేదు, write down that a to c there is no edge. Now this is called as embedded graph. Now so this path is already we have discussed, that is a path is nothing but, so this concept is completed. Okay, ఇక్కడ కూడా this is the path, ఇంతకు ముందు కాన్సెప్టే with another example. Okay, here A B C D, suppose you can observe here A B D C A. This is what is a arc of length 6 is not a closed because end points are not same. Suppose you can observe here A to B, B to D, D to C. Now C to A, A to B, A to B, B to D, D to C. That means again C to A, then this is called as a cycle but not closed. So but ఇక్కడ ఏంటి ఎండ్ పాయింట్స్ సేమ్ కావు కాబట్టి ఇది సైకిల్ కాదు. నెక్స్ట్ యూ కెన్ అబ్జర్వ్ హియర్ దిస్ ఈజ్ ఏ పాత్ ఓన్లీ బట్ ఇట్ ఈస్ నాట్ ఏ here this is a this is a ఇది రాంగ్ ఉందండి. సో దిస్ ఈజ్ ఏ సైకిల్, దిస్ ఈజ్ ఏ సైకిల్ బట్ నాట్ పాత్ కాదు అంటే ఆటోమేటిక్ ఏమవుతుంది క్లోజ్డ్ పాత్ కాదు. ఆ ఎగ్జాంపుల్కి ఎక్స్ప్లెనేషన్ అబో ఎగ్జాంపుల్కి హౌ టు రైట్ ద పాత్స్. అండ్ ఇంకొక కాన్సెప్ట్ ఏంటి అంటే వీక్లీ కనెక్టెడ్. ఓకే, వీక్లీ కనెక్టెడ్ అండ్ స్ట్రాంగ్లీ కనెక్టెడ్ కాంపోనెంట్. సపోజ్ యూ కెన్ అబ్జర్వ్ హియర్ G1, G2 are the graphs. A diagraph is weakly connected if its embedded graph is connected. అంటే ఎంబెడెడ్ చేసిన తర్వాత కూడా కనెక్టెడ్గా ఉంది అనుకోండి, అన్ని వర్టిసెస్ కనెక్ట్ అవుతాయి, దెన్ వీ కెన్ సే దట్ ఇస్ స్ట్రాంగ్లీ కనెక్టెడ్, అదర్వైజ్ దట్ ఈస్ వీక్లీ కనెక్టెడ్. సో నెక్స్ట్ క్వశ్చన్ కేమ్ ఫ్రమ్ ద యూలర్ పాత్. అంటే ఇక్కడ యూలర్ పాత్ ఈజ్ నథింగ్ బట్ యూలర్ పాత్ ఈజ్ ఏ గ్రాఫ్. దట్ మీన్స్ యూలర్ పాత్ in a graph is a walk so that includes each edge exactly once. అంటే each edge exactly once, then that is called as a Euler path. And Euler cycle is a closed walk that includes each edge exactly once. అంటే Euler cycle అనేది ఏంటి అంటే క్లోజ్డ్ పాత్. హియర్ ఈచ్ సైకిల్ ఈచ్ ఎడ్జ్ ఈజ్ ఎగ్జాక్ట్లీ వన్స్. రిపీటెడ్ ఎడ్జెస్ అనేటివి ఉండకూడదు. దట్ మీన్స్ so that type of path and closed path is exist. So then we can say that that graph is a Eulerian graph. That is the Eulerian graph is a graph that has an Eulerian cycle. That means if the graph exists a Eulerian cycle is a closed path with distinct edges, then we can say that that is a Eulerian graph. Okay, Eulerian path and cycle need not have distinct vertices. సో అంటే మనకి పాత్ అండ్ సర్కిల్స్ ఎప్పుడు కూడా సపోజ్ యూ కెన్ అబ్జర్వ్ హియర్ ద క్వశ్చన్ లైక్ దిస్ ఈస్ ఏ, హియర్ ఏ, నెక్స్ట్ సి, ఓకే, సి టు ఈ అండ్ ఈ టు డి, నెక్స్ట్ డి టు ఏ, నెక్స్ట్ ఏ టు బి, నెక్స్ట్ బి టు సి, నెక్స్ట్ సి టు ఎఫ్, నెక్స్ట్ ఎఫ్ టు D, this is what the D, next D to C, next again F, again A. So is an Eulerian cycle. So this is an Eulerian graph. Suppose you can observe here the edges. Okay, A to C edge, C to E edge, okay, E to D edge, D to A edge, A to B edge, B to E edge, E to F edge, F to D edge, then D to C edge, C to F edge, F A edge. అంటే ఏంటి ఇక్కడ వర్టిసెస్ రిపీట్ అవుతున్నాయి బట్ ఎడ్జెస్ మాత్రం రిపీట్ అవ్వట్లేదు, డిస్టింక్ట్ ఎడ్జెస్ ఉంటున్నాయి. ఓకే, అదే మనకి అంటే వర్టిసెస్ రిపీట్ అయితే మనం ఏమంటాం దాన్ని యూలర్ పాత్ అన్నాం, పాతే అన్నాం. బట్ ఇక్కడ యూలర్ పాత్లో ఏంటి అంటే పాత్ ఎగ్జిస్ట్ అవుతుంది అండ్ వర్టిసెస్ సేమ్ ఉండొచ్చు బట్ ఎడ్జెస్ మాత్రం డిఫరెంట్గా ఉంటాయి. సపోజ్ ఇక్కడ దిస్ ఈజ్ అ యూలర్ సైకిల్ మీన్స్ హియర్ దీస్ టూ ఎండ్ పాయింట్స్, దీస్ ఆర్ ద ఎండ్ పాయింట్స్ ఆర్ సేమ్, means this is a cycle, this is a closed path. In this case observe here edges are distinct, not the vertices. సో నార్మల్గా చెప్పేటప్పుడు మనకి వర్టిసెస్ డిఫరెంట్గా ఉండాలి అంటాం. అదే యూలర్ సైకిల్ చెప్పేటప్పుడు వర్టిసెస్ డిఫరెంట్గా ఉండాల్సిన అవసరం లేదు బట్ ఎడ్జెస్ మాత్రం డిఫరెంట్గా ఉండాలి, డిస్టింక్ట్ ఎడ్జెస్ ఉండాలి. సపోజ్ యూ కెన్ రైట్ హియర్ ఆల్ ద ఎడ్జెస్. సపోజ్ యూ కెన్ టేక్ ఏసీ. So this AC is not repeated here. So that's why this is called as a Eulerian cycle. So if this graph exists the Euler cycle, now this graph is called as Eulerian graph. Now this is a Eulerian graph. So now see the questions here. If G is a connected graph, then the following conditions are equivalent. So if it is a connected graph, conditions manaki satisfy kavachu ikkada. That is G is a Eulerian. The degree of each vertex is Eulerian. the set of all edges of G can partitional into cycles. So the next point. So here, and out of these 3 points, which is satisfied? Which is satisfied here? All these. G is, and if G is a connected graph, then the following conditions are equivalent. G is Eulerian, and G is a connected component అయింది అనుకోండి, అక్కడ Eulerian exist అవుతుంది. Suppose if it is a Eulerian, the degree of each vertex is తప్పు మళ్ళీ తప్పు రాసాను. నేను ఈ క్వశ్చన్స్ రేపు ఎక్స్ప్లెయిన్ చేస్తాను. క్వశ్చన్స్ రాంగ్ ఉన్నాయి, నేను రేపు ఎక్స్ప్లెయిన్ చేస్తాను. So this is one of the question. We know that what is the number of edges present in a complete graph having n vertices? N vertices use చేసి ఎన్ని నెంబర్ ఆఫ్ ఎడ్జెస్ ఫామ్ చేయొచ్చు కంప్లీట్ డయాగ్రాఫ్లో అంటే n into n minus 1 divided by 2. n into n minus 1 divided by 2. Okay, here this is the graph, this is some graph. Okay, here the graph G is a regular. This graph is regular? No, this is not a regular graph, because you can take the edges from this A 3. So from here 3, but number of vertices, that means edges, that means all vertices have equal number of edges, that means adjacent with the other vertices with equal number of vertices. Then we can say that is a what? That is what regular means. Regular in the sense every vertex degree is same. That means a regular graph in a regular graph is nothing but degree of all vertices are equal. Then we can say that as a regular graph. So this is here 3, here 3, here 3, here 3, here 3, here also 3. Sorry, this is true regular graph. Suppose you can observe here. Degree for this A 3, 1, 2, 3, degree for this B 1, 2, 3, for C 1, 2, 3, for D 1, 2, 3, for F 1, 2, 3, for E 1, 2, 3. So that this is what? Regular graph. Okay, now simple graph. So when we say that the graph is simple, so the number of edges is equal to the twice the sum of the degrees of the vertices. That means simple graph in the sense the number of edges is equal, that is twice the sum of the degrees of the vertices. And a simple graph in the sense, suppose A to B, B to C, C to A undi. Now this is called a simple graph. That means the number of edges, 1, 2, 3 edges are there. So these 3 edges equal to twice the sum of the vertices. That is here how many number of edges are there? 3 edges. 3 edges twice that edges, that means 2 into 3, 6 equal to a degrees sum. That means 2 plus 2 plus 2. That means A degree is 2, B degree is 2, C degree is 2. That means suppose see here, suppose observe here. Suppose this is some graph A to B and B to C, C to A. So this is some graph. Here this is graph is a simple graph. Okay, in this case number of edges, that means twice the number of edges. How many number of edges are there here? 3 edges equal to 2 into 3, that means 1, 2, 3, twice the number of edges equal to degrees. Degree for this one is 2, degree for this one is 2, degree for this one is 2. That means 2 plus 2 plus 2, sum of all vertices degrees equal to what? 6. 6 equal to 6. Then we can say that this is what? simple graph. Now we can say that this is a simple graph. So this is what the simple graph. In simple graph, the number of edges equal to the twice the sum of the degrees of the vertices. Yes, it is true. The statement is true. Which of the following property does a simple graph not hold? So this is a must be connected. Which of the following property does a simple graph not hold? It means must be unweighted, must have no loops, or multiple edges, must have no simple edges. All these three are not hold. So false statement enti ante must be connected. So this is not hold. Ante which of the following property does a simple graph not hold? So this is not, this is not, this is not. This is not hold, this is not hold, this is not hold. So that ikkada okati only one statement is this one. Okay. Next, which of the following is true? A graph may contain no edges and many vertices. Okay. Which of the following is true? A graph may contain no edges and many vertices. A graph may contain many edges and many vertices. A graph may contain no edges and no vertices. A graph may contain no vertices and many edges. That means many edges and may contain, may or may not be, it contain many edges and many vertices. So a graph may contain equal degree of vertices called regular graph. Okay? Equal degree of vertices. That means suppose you can observe here what is the equal degree. Now suppose observe here, this is some graph here and here. Now we can call it as a equal degrees A, B, C, D. So this is what the equal degree. Suppose the degree of this one is 3, degree of this is also 3, this is also 3, this is also 3. Now this is called as a simple graph. Suppose here some graph E is there. Now like this, here from here to here. Now this is also a regular graph, but this is not a complete graph. This is not a complete graph. So what is the complete graph? Means, so you can observe here each and every vertex is same, but coming to the complete graph, here this is not a complete graph. Why? Because this is not a complete graph. Here five vertices are there. So observe here every vertex connected with remaining all the vertices. So there is no like that type of graph here. Suppose you can observe here, here like this. Here this is one vertex, this is one vertex, this is one vertex, here one vertex, here one vertex. From here to here, next here to here. Suppose you can observe 1, 2, 3, 4. Okay, now here to here, here to here. Okay, now here. Now observe here, this is what a complete graph. The degree for this is 4, this is 4, this is 4, this is 4, this is 4. Now it is called as a complete graph. This is what? Complete graph. In the previous case, regular graph. That is the difference between the complete graph and regular graph. Okay.